Hello everyone, let's look at Leetcode question 356, line reflection. So in this question we're given endpoints on a two-dimensional plane and we need to find if there is such a line parallel to the y-axis that reflects the given points symmetrically. In other words, answer whether or not if there exists a line that after reflecting all points over the given line, the original point set is the same as the reflected ones. Note that there can be repeated points. Okay, before going into depth with these examples, let's look at the constraints. So the constraints are n equals the points dot length, and the values of n will be somewhere between 1 and 40,000. The values of the points ij or xy will be negative to positive 1 billion. And the follow-up says, could we do better than O n squared time? All right, let's take a look. Okay, so here's the code. Let's run through it with the examples. Basically what is happening here, the first chunk of code defines the min-x and max-x values and the set scene. This will define for us the reflection point for the min-x and max-x values. So we do so next in the for loop. We go through every single point and locate the min-x. So we find the minimum x value of all the points, and then we find the maximum x value of all the points and add that to the set. And after we do that, we then calculate the sum. So min-x plus max-x will then be the reflection point, the center point of all of the other points. After we do that, then we go through all the points once more, we loop through them, and we check if the sum minus x, y, is not in scene, return false. This line of code basically checks the opposing x value, the opposite x value, and the y value, which will be the same, in scene. We'll check if it's in the scene. If it is in the scene, that means that the reflected value point does in fact exist. But if this point is not in scene, then we return false because that point is not being reflected correctly. So then let's run through this example. Okay, so first thing we do in this example, we have the points 1, 1 and negative 1, 1. As you can see, it clearly reflects here, but let's still run through this simple example. We define min-x to be infinity, max-x to be negative infinity. Then we go through every single point, and then we define min-x to be the minimum between min-x, which is currently infinity, or 1, which is smaller, 1. So we define min-x then to be 1. And then for max-x, which is bigger, we have negative infinity or 1, the same value we just looked at, the first x value of this point, and that is 1. And then we add this to the set. So the set currently has 1, 1. The next value is negative 1, 1. So we got this 1, 1. Now we're just looking at negative 1, 1. And we do the same thing. So for min-x, which is smaller, 1 or negative 1. Negative 1 is smaller, so it becomes min-x. The next point is 1, which is bigger, 1 or 1, they're the same thing, so max remains as 1. So scene becomes the set of 1, 1 and negative 1, 1. Then we calculate the sum, so add these two together, the min-x plus the max's is negative 1 plus 1, that's 0. This will be our reflection point, our reflection line. Then we check through every point to see if the reflection exists in the scene set, like we said. So, looping through all the points, we have 1, 1 once more, and we check. So, sum is equal to what? Currently 2, or sorry, 0, because negative 1 plus 1 is 0. And then we do sum minus 1, 1, that's negative 1, 1. Sum negative 1 minus 1, 1, that's 1, 1. So these points exist in the scene set. That just means that the corresponding points are existing in the set and they have a reflection value, and it is true. So we return true. Let's look at a more complicated example. Now for this example, we have the following points. Okay, so we have 2, 2, negative 2, 2, negative 1, 4, and 1, 4. So there's clearly a reflection value at x equals 0. But we need to run through the code and check exactly the processes which validate these reflection points. So we define min-x and max-x already as infinite and negative infinity and are set to be an empty set. We loop through every single point and we define min x and max x. We update these values and add them to the scene set. So min x equals infinity, 2, negative 2, negative 2, negative 2. And this makes sense because the smallest x value is negative 2, and the largest x value is 2. So max x equals 2, negative 2, and 2. And as we're doing this, we've filled up our scene set. So the scene set is now the points that we have described. And so then we want to find our reflection line. How do we do this? Well, sum equals min x plus max x. That is negative 2 plus 2 equals 0. So then, once we get the reflection line defined, we can do the final part, which is loop through every point and check if the reflection point exists in scene. If it doesn't, we return false. Okay, so let's run through this part because it's probably the most tricky at first glance. XY in points, that is first, let's go through 2, 2. Sum minus 2, 2. What was sum? Sum was 0. 0 minus 2 is negative 2, and y remains 2. Okay. Is negative 2 in scene? You say, yes, it is. So that means this is true. Next point, negative 2, 2, the value that we just validated as having a reflection point, is sum minus negative 2 and 2. That becomes 2, 2. Okay. Is 2, 2 in scene? Yes, that is just the point we were at, but this is the corresponding reflection point, validated as true. So then we go to the next point. 0 minus 1 is negative 1, and negative 4. So we say that's for this value right here, 0 minus 1, and negative 4 is this point that we just used because we're looping through every single point. And then we check, is this value in the set? It is, it's this value. And finally, we do 0 minus negative 1, negative 4, that's this value. And this becomes 1, 4. Is 1, 4 in the set? That is the case. So far, all of these values have their reflection points defined as true. So this return false statement will never be accessed for this example, and we just return true for this example. So let's once more look at the solution. Let's see if this solution works. Submit. All right. So it works. It's a great solution. Now, what is the time and space complexity of this solution? The time complexity of this solution is O of n, where n is the number of points. This is because we iterate through the points twice, once to find the minimum and maximum x values, and once to check if the reflection point exists in the set. Both operations take O of n time, which simplifies to O of n time. So then, the space complexity is O of n. And we use the set to store the scene points. In the worst case, all points are unique, and we need to store them all into the set. That's it for this problem. Thank you for watching.